Lecture number 4 is about GUI components, so these are all these labels, buttons and text fields and everything else. And there is of course plenty of them in the core Vaadin framework, and there is even more of those in the add-ons directory. What I start with today is the architecture of Vaadin. I will show you the sampler, which is the best way to get to know Vaadin components and Vaadin itself. And I will describe common properties of the components and the list of components, or the most important ones, and show some use cases of them. This is the architecture of Vaadin. There is this 3-tier presentation, application and storage. So the storage is at the bottom, is the database. The presentation is the top, is the web browser. So we have Vaadin client-side engine and Google Web Toolkit running in the browser. And then everything that you see in the middle is the application logic and the framework itself. So there is an application server, the application archive, and then the application itself, so the servlet with everything, components and logic and themes and things like that. This is a picture that you can also find in the book. It shows all the components in the core of Vaadin and all important abstract classes and interfaces. The gray rectangles are interfaces. The orange ones are abstract classes, and you can derive new components from them. And then the blue ones are, of course, components that are ready to use. You can notice 2 sub-hierarchies here. One is the component hierarchy, and the other one, or a sub-hierarchy, is a field. I would say that there are 5 groups of components. So there are simple components which directly follow the abstract component class. Then we have containers, so these are components that can contain other components. We have layouts, so these are components that not only contain other components but also arrange them somehow. We have fields, and then we have selects, which allow the user to select something from a bigger set of options. And this is the same picture but just with abstractions. As I said, the basic interface is called component, so every component in the Vaadin framework implements that particular interface. In itself, it has 2 interfaces, so it extends 2 interfaces, paintable and variable owner. The former paints the component in the browser, and the latter is used for interaction from the client side, so captures the events from the browser and translates them to the server side. The interface defines a bunch of useful properties. I will just go through them in a minute. What is important is that the interface component is paired somehow with a class abstract component, which is something you should use directly. So whenever you develop a new component, you shouldn't implement component interface directly, but instead you should extend abstract component because it provides some useful properties and implements serialization and communication with the browser. Now about sampler. Vaadin sampler is available at the above address, and it looks like this. The screenshots are made deliberately with Internet Explorer to show you that it works even in that browser. Your application will be running as expected in Internet Explorer. So what it features, it features up-to-date version of Vaadin, and all the components, they are nicely organized and they contain source code. So now component properties, these are common to all components. So every component in Vaadin will have them. So the most important property is a caption, which is by definition an explanatory text that accompanies a user interface component. So that's anything that is displayed near the component or within the component itself. And it's plain text, so you cannot use rich text formatting or HTML there. The handling of a caption varies from component to component. So some components, like the button, they display the caption within themselves. And some, like the text field, they rely on parent component to do that for them. So it's not granted that a component will handle the caption by itself, but it is granted that a component will have a caption. This is how it looks on the server side. It's just a string property. As I said previously, everything is rendered as HTML to the browser. We can format it using CSS, and Vaadin takes advantage of that by using class styles. The caption comes with an element that has a class v caption. Everything that is prefixed with v and a dash, it's a Vaadin component or Vaadin element. so you shouldn't use that for your components. And v-caption is something that contains the caption. The caption text is actually the element containing the text, and then there can be something called clear element, which is clearing all the floating elements around. So if you want caption text with a bold font, then you should edit your CSS file to include v-caption text and then the proper rule. The next property, which is similar to caption, is icon, and it's explanatory graphic. It depicts the role, but the important remark should be made here is the accessibility. Not all browsers handle or display images, and not every user is able to understand the picture. So clear text is usually much better. And the trick is that the graphic can be omitted without losing the semantics. So if you have a button with a graphic only, then when the graphic is not displayed, then you are just left with the button that the user has absolutely no idea what it does. So it's a good idea to include some text somewhere and rely on text instead of images. And again, as with caption, the handling of the icon varies. Again, buttons, for example, display the icon themselves, and some other components, they just rely for the layout. And again, this looks quite simple. It's a little different. The CSS rule is just v-icon. To set the icon, we use resource. The most common resource is theme resource, so it's an icon from the current theme set. Lecture number 6 will be about resources and how to handle graphics, streams, and other things that you might be displaying to a user. And the third property is called description, and it's more elaborated than the caption. It's entirely optional. It should provide some information about the role of the component, for example, or what are the allowed values for the component, or what will be the effect of interacting with the component, or something like that. In contrast to caption, descriptions allow HTML. Browsers render this as a tooltip, so when the user hovers a cursor over a component and waits a little, then a tooltip is displayed. And again, this is very simple. It's a string type property. There are no CSS rules for that, so you cannot format it anyway. Next property is locale, or whatever the pronunciation of that is, I always wondered. So it's inheritable property, which means that if the component does not specify it, it's taken from its parent component. If the parent component doesn't have it, then the application setting will be taken into use. And if not, then the system one will be used. It's not available, or the property is not set at construction time, which means you just cannot use it for some straightforward internationalization. And there are no CSS rules, because this is just purely server-side property. We can set locale of the component by just creating a new one. What is provided is the language code according to ISO standard 639-1 and the country code. Finally, there are 5 component flags, as I would say, which means these are Boolean properties. 2 of them, probably the most important, is enabled and visible. Both concern user interaction, in the sense that enabled means that the component is there and it's enabled or disabled to take input from the user. Disabling a component means that you are disabling all the components it contains as well. And the enabled is, of course, the default state. And the CSS rule v-disabled is present in addition to all classes that the component might have. And of course, there is no rule for enabled components, because that's their default and normal state. Visible is something similar. It's just that the invisible component is not passed to the browser, so the user doesn't see it at all. That also means that the component never existed from the browser point of view, and it's impossible to change the state of that component from the browser by hijacking the session and sending malicious code. There is no CSS because there is no component. What will be rendered in the browser is an empty element, which will have an inline style display none, which means you just cannot override it. Another component flag is read-only, visible in all fields. So not all components, but all fields have read-only property. A read-only component will not accept value modifications in any way. So not in a browser and not on a server. It will have a v-read-only CSS rule in addition to regular rules. And finally we have style names, and this is something that allows to name your components to your liking and to use that in your CSS. Each style name is always rendered in two forms, so you can fine-tune the components with the common style name if you need that. The rule is that it cannot cause conflicts, so it has to be a valid CSS class name, and it cannot be the name of any component in Vaadin. This is how it looks. We have a label foo, and we can set style name just by passing space-separated list of styles we want to have. Or we can add and remove one by one, so we can add style name or remove style name if we want. And then there is of course only one getter, which gets you a space-separated string. And these are the CSS rules, so if we use these two lines here, so add style name, style 1 and style 2, we can have these four. So all the labels with this style will have label style 1 and label style 2. If we have buttons, then we will have v-button style 1 and v-button style 2. Both labels and buttons will have style 1 and style 2 class. There are other properties that are common to, if not every component, then at least the majority of them. Two of the most important ones are width and height. It's not in the component interface, it's in a sub-interface called sizable. That's because it doesn't make sense for every component to be sizable, so some of them you might just want to keep the same size all the time. Some of them you just don't want to render at all, and it just doesn't make sense. But fortunately, most of the components, they are sizable. The rule of thumb is that in general you can size the component that makes sense to be sizable. So buttons, panels. Contrary to desktop applications, width and height can be undefined, which means that the component will by default take as little space as possible, but that allows you to fine-tune the width and height in the CSS. Combined with style names, that gives you a pretty powerful tool for setting the dimensions of components. Important thing to notice also is that the default behavior varies. So there are components that are by default undefined in both directions. There are some that are full size in width and full size in height, or both of those. This is again how it looks on the server side. So the left side shows you some code, and we can set the width using CSS string. This will be rendered as an inline CSS. Of course you can do it the Java way, so you can set the number and the unit separately. In this case we are setting the height of the component to be 50% of the parent. There are two shortcuts that come in handy when you want to set size to undefined, or you want to set both to 100%. And here is the method to set height undefined. So there is a special constant called sizable size undefined, which you can use, and that clears all settings about height, so nothing will be rendered in the browser. And then we have two properties which are defined in another sub-interface of component called Focusable. Again, this is not for every component, only for those that it makes sense. Focusable means that the user can actually select this component or focus somehow to it. Of course, every field is focusable. The same rule as with width and height. Whenever it makes sense, then usually the component is focusable. The drawback is that with current implementation, there is no way to find which component is focused. Some components, but not all of them, they broadcast events whenever they receive focus or lose focus, but it is not required for any component to actually broadcast those events. The property that is tightly connected is the tab index. So this is when a user sees a web page, then of course you can navigate with tab. Tabulation will switch the component that is currently active to another one. And you can set the order in which these components are switching focus. So it doesn't have to be left to right or right to left, whatever is in the browser. This is how it looks on the server side. So we have a text field which is focusable, and we can force these fields to get focus by calling a focus method. And then of course you can set the tab index with 0, 1, 2 and so on and so on. The CSS rule is that the component that currently has focus has its style v, component name, focus, and of course there is no rule for the components that do not have focus. Okay, so that complements the... So let's start with the simplest possible component, which is a text label. The role of the text label is to display a text and to allow the user just seeing the text and nothing else. There is very little interaction with that. There are three modes in which label can operate. They are switchable with set content mode. The default one is text, so it shows plain text and automatically escapes dangerous HTML characters. The other mode that you can set is the preformatted, so it's rendered on the browser side with a monospaced font, which is very useful to present, for example, code listings or something like that. Contrary to the plain text, it can contain new lines, tabulation signs, and all the whitespace characters you can think of, and it preserves them. And again, all the dangerous HTML characters are escaped. The third mode that we have is the XHTML.
In this mode, the contents of the label are expected to be XHTML strict. They are rendered inside a div element. The input is not sanitized in any way, so you should be really careful about the data that you display or you allow the user to display through this mode, as it can lead to cross-site scripting attacks. Here is some code for creating labels. So the constructor takes a string as its first parameter. That parameter will be then shown as a caption. We can also set the caption with the setter method. In order to have HTML displayed, we need to set the content mode, otherwise all the dangerous characters would be escaped. And the CSS rule is just v-label. The next component is called link, and as the name implies, it's just a clickable link to an external resource. We can always change the target resource that the link references. The drawback of using link component is that it does not broadcast events, so whenever somebody clicks the link, there is no way to figure out that this particular link has been clicked. And in Vaadin there are at least two other ways of having links. One is a label in content mode XHTML, and the other one is button that is styled as link. The latter is more preferable as it broadcasts events and allows you to trace link clicks. The server-side code is very straightforward. The constructor of link takes two parameters. The first one is a string that will be displayed to the user, and the other parameter is the external resource that the link leads to. And of course there are setters and getters for icons and resource. In the browser this is rendered inside a v-link element. The link itself appears in an a element, and the optional icon is inside the v-icon element. The next component is something you should be familiar with if you have used any desktop application. It's a horizontal menu bar. The only difference is that in Vaadin you can position that anywhere, not only on the top of the screen. The structure is very similar to desktop applications. The main menu bar contains items, which can contain more items, and those in turn can contain even more of them. We add items with a method called addItem that returns us an instance of a class menu item that contains text, icon, and a command to be executed upon clicking. This component is a wrapper for a component found in Google Web Toolkit, hence the unusual class names for the CSS rules. They start with GWT instead of V. Now let's have a look at some code that utilizes the menu bar. We are going to see how to produce a menu structure and bind commands to it with the code on the left. First we declare a label, then the contents of the label will be changed whenever we click a menu item, and we do this by implementing a command interface. The method menuSelected of that interface takes the parameter, which is the item that was clicked, and then we can get the properties of that item to modify the text of the caption. Then we produce a menu bar and add items to it and bind the command to each item we add. Let's run that code in Eclipse. So I will replace the contents of the example project that is generated by the Vaadin plugin with the code I just shown you. Then I will fix all the missing dependencies. Then of course we need to add the components to the layout so that they are actually displayed. And now let's run the project and see what happens. This is how it looks. Now when we click, there are things that change according to our code. Another component we have in the core Vaadin framework is named embedded, and its role is, as the name implies, to embed external resource, so a PDF file, an applet, a stream, or whatever you can embed into a web page. It is important to notice that the three most common cases are excluded. They are called image, flash, and browser frame. The next group of components I'm going to talk about are basic fields, which are simple components that accept a simple single value. All fields allow some sort of interaction with the user, so they broadcast events that can be listened to, for example click events or focus or blur events. Of course, whenever a value is changed, a value change event is broadcasted to all listeners. These components are designed to fit the Vaadin data model, although they can be used without a data source. One of the most commonly used components in this group is a button that can be used to finalize the user input or initialize some action in the software. The button can be automatically disabled on click, and it can also contain an HTML formatted caption. Of course, it can be also clicked in a number of ways, not only mouse or keyboard shortcut, but it can be clicked programmatically through a method call. The constructor of a button takes one or two parameters. The first parameter is a caption that will appear on a button, and the second parameter can be a click listener that handles clicks. This gives a straightforward way to create a button with a listener in one go. One of the simplest fields is a checkbox that's a two-state selection component. This component has two distinct roles. It either confirms something when it's present alone or allows user to select options when in a group. When constructing a checkbox, it is possible not only to specify the text that will appear next to the checkbox, but also whether or not the checkbox is selected. In order to listen to value changes or click events, we need to add value change listener. The CSS rules are very simple. This component is rendered as an input and a label in the browser, and all of that is wrapped in a div element with the class vCheckbox. Of course, Boolean values are not the only type of value you could add to a field. The next group of components are those that accept string as a value. There are three different components depending on a role they play in your software. There is a text field, a typical single-line text input field with a CSS rule vTextField, a text area that supports multi-line text, and then there is a password field, which is a single-line text input field with a hidden text. It is important to notice that the password field by itself does not encrypt its contents, it just hides them from the user. And this is how these components look. The first one is a text field, so it accepts a single line. Then we have a text area which accepts more than one line, and finally there is a password field. You can see that whatever I typed here is hidden. Vaadin supports also rich text area, which is a WYSIWYG editor for HTML formatted text. Contrary to other text fields in Vaadin, this one does not broadcast text change events, so it is not possible to react to changes in the text or changes to part of the text. It is only possible to capture the event that the value of the field has changed. And now let's have a look at this component. So you can see that it's just a regular text field, but it supports formatting, so I can change the background of the text, I can change the style of the font, I can change the size of the text, and all of this will be stored as an HTML formatted string. Two components are available for handling dates. Both of them are subclasses of date field. Inline date field is an inline editor, and pop-up date field is a simple input with a button, and whenever clicked, the button displays a date picker in a pop-up. And this is how the components look. At the top you see a inline date field, so it is a simple field which allows you to navigate through years, months, and selecting dates. Here on the bottom we have a pop-up date field which shows an inline date editor whenever we click a pop-up, and then allows displaying the date in the text field. That's it for simple components. Now let's move on to component containers. So these are components that contain other components but are not layouts. Layouts will be covered in one of the future lectures. The simplest possible container is a panel. It is a component that holds exactly one component, which of course can contain other components, which can contain other components, and they can contain even more components in themselves. Panel provides a caption, an icon, a border, and a scroll bar for its contents, and it also broadcasts clicks unless a component inside the panel handled the click itself. And here is some code to show you how it works. So at the beginning we create an image, then we create a panel, and we set contents of that panel to the image. And now if the image is too big, the scroll bars will appear automatically. The CSS rules for panel are very simple. The main component is inside a V panel. As I said, panel stores only one child component. There are two components that store two child components, both derived from abstract split panel. These components are horizontal split panel and vertical split panel. Horizontal split panel arranges components horizontally, and the split is a vertical line, and vertical split panel does it the other way around. In any case, each of those components contains a split that can be dragged by the user. Optionally, it is of course possible to disable locking and set the split through a method. Here are the CSS rules and an example code to show you how easy it is to construct split panels and how to organize them one into another. So let's see how this code works. This is how it looks. The main component is a horizontal split panel. You can notice that there are scroll bars appearing. And on the right hand side we have a vertical split panel that contains a button as its first component and the label as a second.
We had a component that can contain only one. We had two that contain two, and then we have two that contain any number of them. So this is a multi-component container. It's what you have probably seen in a number of applications at AppSheet. So each component is presented in a separate tab. There is a number of options which you can set up to each tab. So it's a caption, it's an icon, a description which will be rendered as a tooltip, a visibility, availability, and then the ability of the tab to be closed. Current design of the tab sheet is that the tabs are not loaded or rendered in the browser until they become selected, which is very good because it allows you to have complex layouts on many tabs, but only the selected one will be sent to the browser. The headers are arranged horizontally from left to right or from right to left, that is the setting, and the content of the selected tab is displayed below that. If you wish to have a different direction, so from top to bottom, then you can use the accordion class, which is an extension of tab sheet in just that it renders top to bottom. Headers are arranged vertically and the selected tab is displayed between the current tab header and the next tab header. The events that are broadcasted by the tab sheet allow you to capture when a tab has been selected or when it has been closed. An important note is that when there are no tabs and we add the first tab, then it automatically gets selected, and it means that it automatically also broadcasts the corresponding event.
The next group of components are advanced fields. So these are those components that allow selecting options from a data source or from a range of available options. In addition to events that are broadcasted by the simple fields, we can also capture the events whenever the set of available options is changed. Again, as with simple fields, these components were designed to fit Vaadin data model, which is explained later in the course. Most of these components, they have a meaningful behavior without any data source. The most straightforward component is a combo box. It allows a user to select a single value or create new values, optionally of course. It also features dynamic suggestion as the user types in. Native select is a bit poorer in terms of functionality version of combo box. It allows a user to select a single value, but this allows adding new values and there is no dynamic suggestion. List select is a component that allows a user to select a number of values. It's also very simple. It doesn't support adding new values or dynamic item suggestion. In fact, it's rendered in the browser the same way as native select is. Option group is a component that can work either in single selection or multiple selection modes. In the first mode, the options will be shown as a group of radio buttons, whereas in multi-selection mode, all of the options will be shown as checkboxes. Also, it is possible to disable or enable individual items. Finally, there is twin call select. It is a multiple selection component based on two columns. On the left we have available options and on the right there are selected items. It is possible to customize this component by providing a caption for each column or limit the number of rows that are visible. In this screen you can see how all the described select components look like in the browser. So we have a combo box into which we can type and then there will be dynamic item suggestion. The native select looks like a typical select. Then we have a list. Both list and the option group by default are in single selection mode, whereas twin call select is always in a multi-selection mode. What I talked about during the lecture are not all the components that you can find in Vaadin. There are some other ones as well. Two most important components that were missed are data presentation components, table and a tree. Table is, as the name implies, tabular representation. It contains tens of options. It allows custom headers, footers, hiding columns, and so on. We have a tree, which is a hierarchical representation of a dataset. It also contains a significant number of options. Both these components are combined in a tree table, which allows a tabular representation of a hierarchical dataset. More components in the core Vaadin framework include an upload, progress indicator, and a slider. Upload, as the name implies, allows handling uploads from the browser to the server. Progress indicator displays a value from 0 to 1, and it works on the client side by polling the server. And finally, slider is a good component for selecting numerical value from a range. The core framework cannot contain every component for every possible situation. Therefore, if you haven't found a component that you need in the framework, please visit Vaadin directory. There is more than 300 add-ons and components for your software. That's all for this lecture. Today you hopefully learned about component hierarchy, the basic interfaces and the differences between them, some common properties and what they are for and how are they defined, and what are the groups of components and what events do they broadcast and when.